Hey, hello everyone. Today we are going to look at Pythagoras Theorem, and this is from Secondary 2 Mathematics. So, who is Pythagoras from this Pythagoras Theorem? So, Pythagoras was an ancient Greek mathematician and philosopher. So, this guy Pythagoras, he made many mathematical contributions to the field, and Pythagorean Theorem is his most famous mathematical contribution. So according to legend, Pythagoras was so happy when he discovered the theorem that he offered a sacrifice of oxen. So this is symbolic during that time in which when you're happy or you find success, you sacrifice an animal. So what is Pythagoras theorem? So Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides in a right angle triangle. So take note that Pythagoras theorem only works in a right angle triangle. So what does it mean? It means that if I have a triangle, a right angle triangle, okay, and this side is A, one side is A, the shorter side is A, the other side is B, and the longer side is C, which is the hypotenuse. So we can say that A square plus B square will be equal to C square. So for this concept, you just need to memorize this. You just need to know this, you need to memorize this and apply it to questions. So, but before that, before we do the practice and I'll show you some examples, we got to prove that this theorem is true. So I have this triangle, so this triangle here, and I have 4 of it. Put one on this side, put one, the other two on the right side here. So why do I do that? Why do I do that? So that I'll make a shape which has 4 right angles and all the sides are equal, and all the sides are equal to A plus B. So this is actually a square. This whole bigger shape is a square. The 4 similar triangle make up a square. And you can see that there's a smaller square in the middle, the space in the middle here, where all the sides are equal to C. And this yellow square here, the area of this yellow square, the space in the middle is equal to C square. So just take note of that. This is C square. So I'm going to move the triangle, 2 of the triangles up, the 2 triangles up, but I will not add or take away any one or any shape. The entire square here will still remain the same. So first, let's look at this triangle here. So this side here is B and this side is A. So just take note of that. So I'll move it up. So this is B, this is still B. Side, the length of this side here is B. For this triangle here, I'll move it up. So just take note, this is A. So now the space, which is area of the space in the middle, which is C square, has now moved, shifted to the bottom here. The area of this space here is the same as the previous one, the middle, the C square. So this area here I can divide into 2 shapes. And we know that this is B and this is B. So this is a square in which the area is B square. Because this should be B and this should be B as well. What about this green shape? We know that this is A and this is A. Opposite sides are equal, so A as well. So this is a smaller square whose area is A square. So because I say that that's how we say that this space is equal to C square, so the area of these 2 squares here, 2 squares, A square plus B square equals to C square. So this is the first proof to show that the theorem is true. Right? Next, the second proof. So we have a triangle, a smaller triangle. One, the shorter side is A, the other side is B, and the hypotenuse is C. So if I were to draw a square on each side of the triangle, so the area of A here, the square here will be A square. The area of this it will be b squared, and the area of this will be c squared. So we have put a value to the sides. So let's say this 3, this is 4. So 3, 4, 3, the area of this square here will be 9 unit square, and the area of this square here will be 16 unit square. And if 16 plus 9 will be equal to 25, and 25, the area of this bigger square will be 25 square units, in which the side here will be 5. So if you were to draw on a piece of paper 3 and 4, make sure it's a right angle triangle, you find that the hypotenuse will be equal to 5. That's one way you can draw it out. The other way is, if I were to use technology to make animation for this proving of the theorem, okay, I'll use another video from mathsisfun.com. You can check their video link out. I'll put the link in the description. So to use technology, I have a triangle, draw a square below and copy the square on top, cut it up, it will match exactly like what I've shown you earlier. You see that the area of this red square is equal to the area of the blue square at the top earlier on, because it's the same, just copy. Now you cut it up, the blue square, into two smaller squares. You find that the two smaller squares is actually the same, the area are the same as the red square, and this prove the same in the same manner as what I've shown you earlier. 9 plus 16 equals to 25. Alright, this is only possible if you use technology, so that the measurements are accurate and precise. When you cut it up to pieces, it'll be accurate. Okay, what if you don't want to use technology? You want to experiment it, do an experiment. Okay, the other way is, show you another video manner. Okay, we can see that the liquid in the two squares, the small squares, when you flip it over, you will fill up exactly the bigger square. If you flip it back, the liquid in the bigger square will fill the two smaller squares exactly. What does it mean? It means that the area of the two smaller squares is equal to the area of the bigger square. The sum of the two areas in the smaller square is equal to the area of the bigger square. This is the same. It's the same shape as this drawing here. Right. So using the volume of liquid to prove the theorem. Okay, next. So example 1. How do you use Pythagoras theorem in a question? Okay, find the value of x in each of the following triangles. All the measurements are in centimeters. So we have x squared, we have 12, and we have 13. And this is a right angle triangle. So to find x, using the theorem, we have x squared plus 12 squared equals to 13 squared. So if you were to work it out, you find that x equals to 5 centimeters. By right, x equals to 5 or x equals to -5, but we cannot accept the negative value because measurement has to be in positive, Okay, so now what if we modify the question a bit by including an algebraic expression? So now we have x, we have square root of 260, and we have 2x plus 2. But it still works the same manner. Okay, it's still the same. X squared plus square root of 260 square equals to 2x plus 2 square. Right, so there's an error here. It shouldn't be. It should be 2x plus 2. Okay, so when you work it out, you expand it. Okay, and you solve for it. You find that x equals to 8 or x equals to negative 32 out of 2. So you reject the negative value. Okay, next. So practice 1. Determine if each of the following is a right angle triangle. So for triangle ABC, triangle PQR, and triangle XYZ, we have the values of each side given. So you got to draw the triangles out, include the length of each side, and using a square plus b square equals to c square, you need to check whether the value match up. Okay, whether the value of a square plus b square is actually equals to c square, the longer side. And if it doesn't match, it means that the triangle is not a right angle triangle. Right, so for A and B, yes, they are a right angle triangle. And for C, when you do it, you find out that yeah, it doesn't match. A square plus b square is not equal to c square. That's why C is not a right angle triangle. Okay, next, practice 2. A short word problem. So the area of a right angle triangle is 275 square centimeters, and the length of the shortest side is 8 centimeters. So find the perimeter of the triangle. So first, you got to draw the triangle out. Label the shortest side as 8 centimeters and the other two sides as A and B. You can use X and Y. Doesn't matter. Just use any letters to symbolize the unknown sides. And the area is 275 square centimeters. So we know that area is 275. So half times 8 times A equals to 275. So A will be equals to 68.75. So once you know A, we know 8 centimeters, you can use A square plus B square equal to C square, which is A square, which is 68.75 square, plus 8 square equals to B square. So B is 69.214 centimeters. So that is not the final answer. The final answer, you got to find the perimeter of the triangle. So when you add all the sides together, you will get 146 centimeters. And this is correct to 3 significant figures. Okay, practice 3, I did not include practice 3 because it's from another video. I will put the link up if you would like to do more practice on real life situation for Pythagoras Theorem. Okay, so we'll skip to practice 4. So practice 4 is actually taken from a Singapore school, the school's end of year exam paper, question 5, paper 2 from 2015. Alright, so the question states that in the diagram, AP is perpendicular to BC. So if AP is 10 centimeters and AC is 26 centimeters, angle BAP here is 31 degree. Calculate angle PAC. So for part A, they ask you to find the angle. Okay, this is not possible using Pythagoras theorem. Okay, so it's only possible if you use trigonometric ratio. So you can see that in a question, Pythagoras theorem may not be tested by itself. It may be included with other concepts, such as usually with trigonometric ratio. So you will learn trigonometric ratio in another video. So you have learned already, you find that the answer for angle PAC will be equals to 67.4 degree. I will not explain trigo ratio in this video. Alright. Okay, what about part B? Part B, you got to find the length of PC. And yes, you can use Pythagoras theorem. Why? Because you know two sides. And this is a right angle triangle. APC is a right angle triangle. So PC square plus 10 square is equal to 26 square. So you calculate it, you find that PC is equals to 24 centimeters. Okay, what about PB, part C? Not possible using Pythagoras theorem. Why? Because you only know one side, AP. You know one angle, 31 degree. Okay, so you have not enough information. So the only way is to use trigonometric ratio. To calculate it, you find that PB is equal to 6.4 0.01 centimeters. Okay, the last one, the shortest distance from P to line AC. So from P to line AC, if you were to draw a line to show the shortest distance, that line must be perpendicular to AC. So if I draw a line and I will say that the point where the line meet on AC would be equal to O, so we can say that this is the line here would be PO, right? So first you got to find the area of APC. Alright, area of APC, because you know PC is 24, so area will be half times 10 times 24, and this is equals to 120 square centimeters. Once you know the area of triangle APC, now you use AC as the base, then PO, the shortest distance, will be the height. So half times PO times 26 is equals to, must be equals to 120. So calculate this, you can find that PO, the shortest distance, is equals to 9.3 out of 13 centimeters. Alright, so we can see that figure ratio, Pythagoras theorem, and area of triangle concepts, three concepts are being tested in one question. So it's possible. Usually it's like that. Okay. Alright, so do more practice. Try our best, and that's all for this video. Thank you.